Hello and welcome to this quiet corner where the hum of the outside world fades away and the universe has all the time in the world to tell its story. Above you, the night sky hangs like a velvet curtain, stitched with familiar constellations, Orion's belt, the curl of the Big Dipper, the silent wink of Sirius. But tonight, as your gaze drifts between those distant fires, something feels off. It's not the sort of difference you can point to, like a missing star or a sudden comet. It's subtler than that, a pressure you can't see, but your instincts whisper about it, the way animals can sense a storm before it breaks. So before you get comfortable, take a moment to like the video and subscribe. Tonight, we're not going to stay in the present. We're going back in time, far in the past, so far in the past that even the world beneath our feet seems unfamiliar. Now, turn down the lights, turn on the fan for some soothing sounds, and enjoy tonight's journey. Far beyond the reach of telescopes, drifting in the darkness between the stars, something ancient has been traveling for millions of years. It carries no light of its own. It makes no sound, but the space around it bends, as if the universe is leaning toward it. A black hole, a stellar remnant from a star that died long before humanity walked the Earth, is approaching the outer edges of our galactic neighborhood. It doesn't come fast, not by cosmic standards, but in the quiet timeline of the universe, its pace is relentless. From your vantage point here on Earth, you wouldn't notice at first. Even the most advanced observatories would miss it until its influence on the fabric of space became too strong to ignore. The first hints might come from a team monitoring the slow orbits of stars in our local spiral arm. They'd see something strange, the tiniest wobble in the paths of distant suns, a wobble that makes no sense unless there's something massive, very massive, exerting a pull from the dark. Black holes are masters of disguise. They don't shine, they don't reflect. The only way to know one is there is by what it does to its surroundings. Out in the distant reaches beyond Pluto, comets frozen for billions of years in the Oort cloud begin to drift ever so slightly. Imagine ancient ice shards, some larger than mountains, stirring in the darkness like sleepy fish sensing a change in the current. You might picture this as a tiny quiver, but in the scale of the solar system, even a small shift is monumental. The black hole's gravity works like a whisper, pulling gently but persistently, changing the music of orbital dances that have gone on unchanged for eons. Scientists have seen similar wobbles before. Neptune, after all, was discovered because Uranus's orbit didn't match predictions. But this is no hidden planet. This is something far stranger. Somewhere in the control room of a deep space observatory, a technician sips cold coffee and watches the data scroll by. Numbers aren't matching up. The probe we sent past Pluto years ago, still dutifully pinging back information, has drifted off its expected path by a fraction of a fraction. Not enough to alarm the public, yet, but enough to make astrophysicists exchange late-night emails with subject lines like, "We might have a problem." And here you are, lying beneath the quiet sky, unaware that this ancient traveler is drawing nearer. The black hole itself is no larger than a city, but its mass is many times that of the sun. If it were to replace the sun in the sky, we wouldn't just be in darkness, we'd be gone in less than a second. But for now, it's still far away, moving slowly, almost politely. You could almost laugh at the thought, an object that dangerous just drifting by. Like a bear wandering into the edge of a village and sitting down to scratch its ear. Not here to destroy. Not yet. The beauty, if you can call it that, is in the stillness. From its position, the black hole sees the sun as just another bright dot among billions. It doesn't care about us, our fragile blue planet, or the stories we tell under starlight. Its course is set, and we are simply in its path. In this unified world of stars and silence, danger arrives not with an explosion, but with a ripple. And if you listen closely, you can almost hear it. Not a sound through the air, space is too empty for that, but a hum in the mathematics of the universe, in the geometry of space-time itself. A presence that wasn't there before. The night feels colder. Somewhere deep inside, you realize the familiar constellations have begun their slow, invisible stretch, like a painting being pulled at the edges. And even though you can't see the cause, you know something has stepped onto the stage. The pull is so subtle at first that no one notices except the machines. Silent guardians of data perched in mountaintop observatories and drifting aboard space telescopes. Their records start showing tiny variations in planetary positions. A few scientists dismiss it as noise, calibration error, or some misbehaving sensor. But the ones who keep watching see a pattern, and patterns are rarely accidents in the language of the universe. You're still here on Earth, going about your life. You sip your morning coffee, scroll through headlines, maybe glance at a photo of Saturn in your newsfeed. Everything looks perfectly ordinary. But above your head, the solar system is being rewritten, one invisible tug at a time. It starts in the farthest reaches, where Pluto, Eris, and a swarm of icy wanderers make their slow circuits around the sun. Imagine the solar system as a perfectly tuned mobile, its delicate balance maintained for billions of years. The black hole is like a passing breeze, a subtle touch that nudges the outer ornaments. They don't swing wildly, not yet, but their motion shifts enough to send ripples along the strings toward the heart of the system. Gravity is a patient artist. The changes it paints happen over years, sometimes centuries, but the brushstrokes start now. A comet you've never heard of, one discovered decades ago and forgotten except by the astronomers who track such things, finds its orbit stretched, like a loop of elastic slowly pulled longer. Out there, in the cold and dark, it begins a slow inward fall toward the sun, a journey that will take decades, but has already begun. In the scientific community, rumors start to circulate. A few researchers whisper the phrase rogue black hole in conference hallways, then chuckle as if it's just a joke. But jokes often grow from uneasy truths. They remember that black holes aren't rare. They drift through galaxies like sharks in deep water, unseen until they're close enough to bend the light around them. As the months pass, those gravitational ripples grow. Orbits of small, distant objects begin to change more noticeably. Even the planets feel it, though their massive momentum resists. Jupiter's position is off by a whisper, a shift so small it's almost meaningless, but not to the people whose lives revolve around precision navigation. Spacecraft in the outer system require more course corrections than before. Engineers scratch their heads, unaware they are wrestling with the faint edges of a cosmic tie. One night, an astronomer in Chile captures an image of a background star that looks wrong. Instead of being a perfect point, it's distorted, smeared into a tiny arc. Days later, another observatory reports the same effect from a different star in the same region. Light, they realize, is being bent. This isn't a telescope glitch. It's lensing. The telltale fingerprint of something massive lurking between us and those stars. You picture it as ripples on a pond after a stone drops in. Only this pond is space-time, and the stone is heavier than anything you can imagine. You can almost see it in your mind. A patch of sky where the stars shimmer unnaturally, their light curving along invisible paths. Somewhere in all this seriousness, there's a moment of absurdity. A late-night talk show runs a joke about the black hole being like that one relative who shows up uninvited and eats everything in your fridge. It's a laugh, a release of tension. But the truth beneath the humor is that this guest doesn't ask permission to stay. Meanwhile, deep space probes detect something even stranger. Tiny variations in the rate their clocks tick. Time dilation, the black hole's gravitational field stretching not only space, but the rhythm of time itself. These effects are still minuscule here on Earth, but in the data they are clear. Time isn't quite what it was yesterday. In this unified world of cosmic cause and effect, every tug, every bend, every tick of the clock is connected, and the connections are tightening. You can almost imagine the black hole itself, silent, unlit, crossing the vast gulf between stars with all the patience of eternity, finally beginning to reach out and touch the edge of our solar system. You lie under the night sky again, perhaps more aware now. Somewhere out there beyond sight, a tide is coming in. And though the beach still looks dry, you know the water has already begun to rise. The first place you truly see its touch is in the Kuiper Belt, that sprawling ring of frozen worlds, comet cores, and icy rubble that circles the sun far beyond Neptune. It's a realm so distant and dim that sunlight there is little more than a pale memory, a faint glimmer you could block with a single coin held at arm's length. Out here, orbits are slow and quiet, measured in centuries. Or at least, they used to be. Now something is stirring. The black hole's gravitational murmur reaches this cold frontier, and the Kuiper Belt begins to lean toward it, like a field of tall grass caught in a breeze you can't feel. Tiny shifts in trajectory become amplified over time. Pluto's path changes by fractions of a degree, but that's enough to puzzle the astronomers who've tracked its dance for decades. You imagine one of these icy worlds, a lonely sphere of rock and frozen methane, its surface cracked by eons of cold. It hasn't seen change in millions of years, and now, ever so slightly, it begins to drift, as though something far away is whispering its name. That whisper grows louder. Distant probes, like Voyager 1 and 2, the silent messengers we launched in the late 1970s, have been wandering through interstellar space for decades. They're old now, their instruments tired, but they're still listening. And lately, the signals they send back show subtle distortions. Voyager 1's orientation has shifted, its path bent just enough to demand extra thruster burns. Mission Control wonders if it's cosmic rays, onboard glitches, or simply age. But deep down, a few of the engineers know better. The universe itself is changing course beneath them. News of these anomalies leaks into the public. It's small at first, buried in niche science articles with dry headlines like, "Outer solar system objects show orbital drift." But social media does what social media always does. Soon there are memes of Pluto being pulled over for swerving out of its lane, and jokes about the black hole stealing our planets. There's even a viral video of someone tossing a donut into a cup of coffee and claiming it's a simulation of what's happening to the Kuiper Belt. Beneath the humor, though, there's a creeping sense of unease. The Kuiper Belt has always been stable, the icy guardrail of our planetary family. If it's being disturbed, that means the black hole's reach is no longer a distant theory. It's a present reality. Astronomers begin mapping the changes in detail. They notice that smaller bodies, the size of city blocks, are reacting first, their low mass making them easy prey for subtle gravitational nudges. Some start moving on paths that will send them inward toward the sun. It's a journey of decades or centuries, but once begun, it can't be undone without extraordinary effort. Meanwhile, there's a moment of almost poetic coincidence. As the Kuiper Belt wobbles, the James Webb Space Telescope captures a faint background quasar being lensed by something in our direction. The image is stunning. The quasar's light is bent into a delicate arc like a smile in the darkness. It's a smile made by the black hole itself, though of course, it doesn't care. Here on Earth, you might not notice any of this in your daily life. The tides still come and go, the moon still hangs in its place, but the changes out there are like the first tremors before an earthquake. You don't feel them until the ground has already begun to shift. In this unified world where every particle and planet feels the others, the Kuiper Belt has always been a quiet chorus on the edge of the stage. Now, that chorus is changing key. Its icy members lean toward an unseen conductor, and the song they're singing will carry its echoes all the way to Earth. As you lie awake, the thought drifts through your mind. Space is not empty. It's an ocean, and we're just a small boat on its surface. Somewhere beyond sight, a wave has started to rise, and whether we're ready or not, it's coming our way. It's strange to think that something you can't even see can change the pace of time itself. Out in the black hole's neighborhood, moments stretch. Seconds linger just a little longer before they pass, though you wouldn't notice unless you had two clocks, one here, one there, ticking side by side. And if you did, you'd see it. The one near the black hole falling behind, its hands moving more slowly, as though reluctant to let go of the present. This is gravitational time dilation, one of the strangest gifts of Einstein's general relativity. The stronger the gravity, the slower time flows. You might have read about it or seen it in a movie. Astronauts visiting a planet near a black hole and returning home to find that decades have passed. It feels like science fiction, but it's real science, and it's beginning to whisper at the edges of our own system now. On Earth, the difference is still imperceptible, a few billionths of a second at most, but our machines are precise enough to measure it. The atomic clocks aboard deep space probes are no longer matching their twins back home. GPS satellites in Earth's orbit, so dependent on precise timing, require slightly different corrections than before. The changes are small, but they're real, and they're growing. You picture it in your mind. The solar system is a vast clockwork, each planet a gear spinning at its perfect pace. Now the black hole has pressed a finger to one side of the mechanism, and the teeth still turn, but at slightly different speeds. Over time, those tiny mismatches add up. Some scientists react with excitement. After all, this is a rare chance to test the extremes of physics without leaving home. Others are quietly uneasy. Time isn't just a number on a clock. It's the rhythm by which all life moves. Change the beat, even a little, and you change the dance. A random and almost absurd side note emerges. One research team compares the time drift to a jazz band whose drummer is slowly, almost imperceptibly stretching the beat. At first, no one notices. Then, the whole song feels off. They laugh about it in a seminar, but no one misses the seriousness under the joke. Meanwhile, astronomers aim their most sensitive instruments toward the suspected region of the black hole. They can't see it directly. It's too small and too dark. But they can see the way starlight bends around it. The background stars appear to shimmer as if someone were swirling a spoon through the sky. This isn't a trick of the atmosphere. It's the warping of space itself. There's a strange comfort in knowing that the rules are still the rules. The black hole is behaving exactly as physics says it should. It isn't accelerating toward us like some runaway predator. It's simply drifting along the path it's had for millions of years. But comfort is a relative word. Comfort for scientists doesn't always mean comfort for the rest of us. In this unified world, where every motion and moment is connected, the black hole's influence is like an unseen tide lapping at the edge of the shore. We don't see the water yet, but we can feel the dampness creeping into the sand. You imagine for a moment standing on the event horizon, the invisible boundary where gravity is so strong that not even light can escape. From that point, the universe beyond would appear frozen in time, the stars hanging motionless, their light stretching into deep red before fading away. Inside that boundary, there is no return. But here, far away, we're safe, at least for now. As you close your eyes, you can almost feel that slowed heartbeat of the universe, the drawn-out seconds that belong to the black hole's domain. And somewhere deep down, you wonder, if time can change like this, what else will it take with it? The first time you notice it with your own eyes, it's subtle. So subtle you might think it's your imagination. You're out one evening, gazing at the stars, when something about them feels different. They're still bright, still sharp, but there's an odd shimmer, a warping, like heat rising from a road in summer. Except this is no mirage of warm air. This is light itself bending through warped space. Gravitational lensing, they call it. The black hole's mass is so immense that it curves the very fabric of spacetime, forcing light to follow those curves. Distant stars no longer look like single points. They stretch into thin arcs, halos, even ghostly doubles. It's as though the sky has become a great cosmic funhouse mirror. Only this isn't distortion from glass. This is the true path of light, revealed. You picture the sun setting behind a mountain. Normally, you'd have to wait until it clears the ridge to see its light, but a black hole can bend light from behind itself into your eyes, letting you glimpse something that should be hidden. That bending, if strong enough, can even create a perfect ring of light called an Einstein ring, a glowing circle in the dark, like a lantern in a fog. Astronomers begin to record these warped images night after night. The lensing isn't dramatic yet, but it's unmistakable and growing. What was once the realm of distant galaxy surveys is now playing out in our own backyard. The black hole isn't just tugging at orbits, it's reshaping the very view we have of the universe. For scientists, this is gold, a chance to study lensing up close. They can calculate the black hole's mass, its speed, even its trajectory, simply by analyzing how light bends around it. But for you, lying beneath the sky, it's unnerving. Those constellations you've known since childhood are bending, stretching, turning into something unfamiliar. There's even a curious side effect. One observatory in Hawaii reports seeing a background supernova twice. Once as the original explosion's light reached Earth, and again days later as the black hole's lens bent a longer path toward us. It's as if the universe pressed replay on a cosmic event. Somewhere in the control room, a young astronomer jokes that it's like watching a movie twice for free. The black hole itself remains invisible, a perfect void, surrounded by a distorted halo of stars. If it were closer, you'd see its accretion disk, a glowing ring of matter heating up as it falls in. But here it drifts quietly, content to bend light without swallowing it. In this unified world, where light itself bows to gravity's will, the effect is mesmerizing. You can't help but think of the sky as an enormous sheet of water, with the black hole as a pebble dropped in, sending ripples that twist every reflection. And while part of you wants to be awed, and you are, another part whispers that this is just the beginning. If the light from distant stars is already bending, what will happen when its pull reaches the planets themselves? Somewhere far above the clouds, the black hole drifts onward. The lensing grows stronger. The night sky is changing. And the universe, for the first time in your life, feels like it's leaning toward you. You can only watch the strange bending of starlight for so long before the question rises in your mind. What exactly is this thing? The black hole feels like a phantom guest, invisible, uninvited, yet impossible to ignore. To understand what's happening, you trace the story of how humanity first came to believe in such bizarre creatures. It begins, in a way, with Einstein. In 1915, he unveiled general relativity, a theory that told the world gravity was not an invisible force tugging at masses, but the warping of space and time itself. Massive objects, he said, bend space-time, and other objects move along those curves, much like marbles rolling along a stretched rubber sheet. It was revolutionary. But Einstein himself didn't believe black holes were real. They were strange, unsettling consequences of his own equations, points where density becomes infinite and the laws of physics as we know them break down. He thought nature would find a way to avoid such extremes. Still, a few scientists, like Karl Schwarzschild, took the math seriously, describing how such an object might work. For decades, black holes were just a mathematical curiosity. Then the universe began to reveal its hand. In the 1960s, astronomers discovered quasars, impossibly bright beacons from distant galaxies, powered, it turned out, by supermassive black holes swallowing matter. In the 1970s and 80s, X-ray telescopes detected the telltale emissions from smaller, stellar mass black holes, like the one in the Cygnus X1 system. And then, in 2019, came the first direct image. The Event Horizon Telescope, a network of radio observatories spread across the globe, combined their data to capture a blurry orange ring, the shadow of a black hole in galaxy M87. It wasn't a sharp photograph. It was more like the ghost of an outline, the silhouette of the unseeable. But it was proof. You think about that as you imagine the one now drifting toward us. It's likely a stellar remnant, the collapsed core of a massive star that exploded in a supernova millions of years ago. Its mass could be 3, 5, maybe even 10 times that of the sun, all crushed into a sphere barely the size of a city. And here's a random, oddly grounding thought. If you somehow replaced Earth with a black hole of the same mass, our orbit would remain exactly the same. The planet's mass is what determines our gravitational pull, not its size. Of course, you wouldn't survive the change, the surface would be gone, but the sun wouldn't notice the difference. It's a reminder that what makes black holes terrifying isn't their gravity at a distance, but their pull if you come too close. As you lie there, the history and the present merge. A century ago, black holes were speculation. Today, they're mapped, studied, even heard, as LIGO records the gravitational waves of their collisions. And now one is writing itself into the solar system's story. In this unified world where the past of science folds into the present of experience, the black hole is both a chapter we've read and one we are now living. Humanity has always watched the skies with curiosity, but tonight you feel the gaze returned. Not by eyes, but by an ancient presence moving silently toward us. And you can't help but wonder if the scientists who first imagined these objects would have felt awe or dread to know one was coming. It begins as a faint shimmer in the farthest dark, a glittering tail against the black, like frost catching morning light. Then more appear, not meteors streaking through Earth's atmosphere, but swarms of icy fragments falling inward from the deep. The Oort cloud, that vast shell of ancient comets stretching halfway to the nearest stars, is waking. The black hole's gravity has reached it. For billions of years, those frozen bodies have drifted almost motionless, preserved in a deep freeze since the birth of the solar system. Now they feel the pull, a subtle nudge that shifts their orbits. Some are sent tumbling toward the sun for the first time in their long existence. From Earth, you wouldn't see them yet. But high-powered telescopes do, catching pinpricks of light as comets begin their long plunge. It's the largest migration of icy bodies humanity has ever recorded. Astronomers calculate that over the next century, the inner planets will see more cometary visitors than in the last million years. The first to arrive are the small ones, city-sized chunks of rock and ice that flare brilliantly as they near the sun. One night, the sky erupts in a meteor storm so intense it turns night into a shimmering false dawn. For hours, streaks of light cross the heavens, their trails glowing long after they burn away. People gather outside, pointing and gasping, some making wishes, others simply silent. And in the midst of it all, there's a moment of levity. A news anchor, covering the event live, quips, "Well, at least if the black hole eats us, we'll go out with fireworks." The clip spreads online in seconds, and for a brief while, the fear softens into humor. But scientists are less relaxed. The increased debris means a higher risk of impacts. Most will burn harmlessly in Earth's atmosphere, but larger ones, those kilometers across, could cause regional or even global disasters. Planetary defense teams begin tracking thousands of new objects, updating collision probability charts daily. Meanwhile, the black hole's tug doesn't stop with comets. Dust and gas from the outer reaches begin to drift inward, creating a faint ethereal glow in the outer solar system. Spacecraft cameras capture delicate curtains of light as sunlight scatters through this growing veil. It's beautiful, like a cosmic aurora, but also a sign of just how far the black hole's reach has spread. In this unified world, cause and effect ripple outward like rings in water. The pull on the Kuiper belt feeds into the Oort cloud, which sends its icy messengers hurtling inward, which in turn light the skies of distant planets and the homeworld alike. You watch one of those meteor showers from your own backyard, bundled against the cold. A faint smell of ozone lingers in the air, and the hiss of burning dust drifts down from above. For a few seconds you imagine you can feel the solar system tilting, ever so slightly, toward its silent visitor. And somewhere, beyond the reach of your eyes, the black hole drifts closer still. Far beyond the asteroid belt, the giants of the solar system have always kept watch. Immense worlds whose gravity shapes the orbits of moons, comets, and even one another. Now, they too are beginning to feel the black hole's pull. It's not a sudden lurch or a violent jerk, but a steady, patient tug, like a distant tide drawing everything in its direction. Saturn is the first to reveal the change in a way you can see. Its famous rings, made of ice and rock, have always formed elegant razor-thin bands. Now, subtle waves ripple through them, spirals curling outward as particles shift under the combined gravities of Saturn and the approaching black hole. Through a telescope, the change is mesmerizing. The once perfect rings look like the grooves of an ancient record slowly warping under heat. Neptune, farthest of the classical planets, begins to wander from its well-known track. The shift is tiny, a fraction of a degree, but the calculations are undeniable. The math says it's drifting toward the black hole's side of the sky. To most, that means nothing. To navigators and mission planners, it means everything. Spacecraft relying on its position for gravitational assists will now need new trajectories. Jupiter, the behemoth, reacts differently. With its enormous mass, it tugs back, resisting the pull. For a while, it's a cosmic tug-of-war. Jupiter's gravity pulling one way, the black hole's the other. The result is a slow oscillation in Jupiter's orbit, a delicate sway that throws tiny disturbances toward the inner planets. Moons feel it too. Titan's orbit around Saturn shifts by meters each month. Europa drifts a touch farther from Jupiter. And Triton, Neptune's captured moon, begins to trace an orbit that no longer quite matches the predictions made decades ago. There's a strange, almost playful moment when a team at the European Southern Observatory renders a simulation of the outer planet's new dance. The visualization, sped up thousands of times, makes them look like wobbly marbles rolling around in a dish. Someone sets it to waltz music, and the clip goes viral. For a day or two, the black hole waltz is a social media trend. But beneath the humor lies an undeniable truth. The architecture of the solar system is no longer fixed. The black hole is rearranging the outer planets in ways no human has ever witnessed. Over thousands of years, such changes could reshape everything: the orbits of moons, the flow of asteroids, even the climate of the inner planets. From Earth, you can't feel the shift in your bones, but you can see the telescopic images, the small but steady differences from last year's charts. And if you close your eyes, you can imagine those vast worlds, each big enough to swallow Earth whole, slowly sliding in their lanes, drawn by a darkness they can't see. In this unified world, where even giants bow to the will of gravity, the black hole is no longer just a visitor on the edge of the map. It's a sculptor, and the solar system is its clay. And somewhere, beyond the frost of Neptune and the storm belts of Jupiter, it keeps drifting closer. You don't feel a jolt. You don't hear a crash. The first signs arrive as whispers, tiny mismatches between expectation and reality that only reveal themselves when someone, somewhere, looks closely enough. You're walking along the shore one cool morning, the salt air sharp in your lungs, the hiss of waves slipping across pebbles, when a lifeguard glances at a tide chart and frowns. Low tide is a little late. Not minutes, not yet, but enough to wrinkle a forehead. Across the planet, the quiet instruments notice first. Superconducting gravimeters buried in basements feel a feather's weight of extra pull. VLBI radio dishes, spread across continents, triangulate quasar signals and come up off by a hair's breadth. The network that keeps Earth time honest. Atomic clocks, satellite links, algorithms sipping data like espresso shots, adds a few more corrective drips to keep everything aligned. The black hole's distant tug isn't rewriting the day, but it's leaning on the metronome. You feel it, indirectly, in the tools you trust. Your phone's maps load, blue dots steady, but the constellation above those apps, GPS, GLONASS, Galileo, Beidou, needs more frequent nudges. Satellites drift a whisper off their lanes, and flight controllers tap in extra station-keeping burns, ion engines humming like soft fans in the night. Precision farmers wonder why their tractors' pads are a few centimeters off. Surveyors tell stories about laser lines that used to land perfectly and now land almost perfectly. Almost is where the whispers live. 100 laboratories compare clocks. Onboard timers aboard geosynchronous satellites age microscopically differently from their twins on the ground. The correction tables get a new column, small and growing. You remember the tale of how we came to live in this world of precision, 1957's International Geophysical Year, when scientists knit a planet-wide web of instruments and Sputnik's beeps stitched the sky to the ground. That was the start of the satellite age, the reason we can measure a late tide to fractions of a minute. Tonight, those same legacies register a new kind of nudge. Not the Earth's, not the Moon's, but something colder, further, heavier. On the open ocean, shipboard inertial systems and star trackers confer like seasoned sailors. The stars they consult are subtly bent. They're like time-shifted by the same warping you've watched in the night sky. The navigation computers adjust, sigh, and carry on. In a coastal city, a science museum's Foucault pendulum traces its slow ellipse beneath a glass dome. A docent, used to the swagger of Earth's rotation, notices a long-term residue in the data, a pattern that shouldn't be there if only sun and moon were playing the tune. It's tiny, cautious, but persistent, like a fingertip on a spinning coin. You stand at the edge of a tidal flat at dusk. Mud gleams like old bronze. The wind smells faintly of iodine and seaweed. A buoy bell clanks. Foam hisses. A distant foghorn draws a long, mellow line across the water. Somewhere behind those sounds, you imagine the faintest, deeper note. Gravity's bass string plucked by a traveler you'll never see directly. The moon still rules these waters. The sun still lends its hand. But their duet now has a soft accompaniment, and the ocean answers with a slightly different sway. A random, unusual ripple makes the news for a day. In a famous surfing bay, slack water arrives just off schedule, and a local competition delays its heats. The announcer laughs about cosmic hang time, and the crowd hoots. Later, oceanographers publish a short, careful note linking the timing shift to subtle tweaks in the Earth-Moon-Sun balance under the black hole's far-off influence. The surfers just remember the water feeling a bit stubborn. Up above, Earth-observing satellites tasked with measuring our planet's gravity field, missions like Grace once did, piece together maps that change by hairline measures from month to month. Mass slides back and forth in the oceans, as always, but the background model those maps ride on needs a new parameter. The international ephemeris teams, the quiet heroes who keep track of where everything in space is, release a bulletin with fresh coefficients. Mission planners bookmark it. Amateur stargazers don't notice. The constellations still look like old friends, even if those friends are standing a millimeter closer than last year. At an airport, a jet pushes back into violet evening, its nose gliding toward a runway that reaches for a dim horizon. The pilot's displays flicker with satellite fixes and radio beacons. Everything aligns, as it must. You think of the chain behind that smooth roll, the clocks, the orbits, the beams, and how every link is now being held with just a touch more care. You can't hear it from Seat 22A, but the sky's orchestra has added a new instrument, and the conductor is distant, blind, and perfectly patient. In classrooms, teachers borrow the moment. A physics teacher shows the class an old photo from 1919, Eddington's eclipse plates, the first time humanity saw starlight bent by gravity, and then pulls up last week's lensing image from a university observatory. A line runs from that century-old day to this one on the board. Gravity curves light. Light tells us where the mass is. Mass tells us a story. The story right now is that something heavy is near enough to matter, far enough to remain polite. For the moment. The satellite controllers joke softly among themselves about sending the black hole a bill for all the extra fuel. The tide forecasters smile thinly at their own graphs. A penguin keeper at a seaside aquarium reports that the tide pool pumps tripped an alarm at a weird hour, and the penguins looked offended. It's a tiny, local flare of chaos in a world that otherwise hums along. You file it with the slackwater surf delay and the pendulum's stubborn ellipse. Little human bookmarks in a cosmic chapter. In this unified world, where ocean and orbit and atom all keep time together, a distant guest has rushed a knuckle against the clock. You can't see the hand move, but the seconds feel a shade longer, the water a shade later, the satellites a shade needier. None of it is dramatic. All of it is real. You walk home under a sky that feels a touch deeper, a touch slower. The evening air soft against your skin. A streetlight hums, leaves click. Somewhere, in the quiet geometry above you, the black hole keeps sliding past the outer markers, indifferent and exacting, tugging at the edges of everything you rely on without ever breaking the spell of an ordinary night. You unlock your door, step inside and close it gently, as if not to wake a sleeping house. You've been feeling the tug in tides and clocks, in satellites and faintly bent starlight. Tonight, your mind drifts farther, to the place where explanations thin and the sky's grammar changes, the event horizon. You don't fly there in a ship. You walk there in thought, soft-footed across the dark. Ahead, the stars smear into arcs and crescents, like candle wax melting into rings. Near the black hole, a compact star mass ghost, there's a shell where light itself can orbit, a photon sphere, a delicate racetrack for photons at 1.5 times the Schwarzschild radius. Just outside, starlight bends. Just inside, starlight circles. Deeper in, even the notion of direction begins to fray. You imagine hanging for a moment above that boundary, engines whispering. They would have to whisper forever, and you feel what physics says you must. Time tugging at your wristwatch, space leaning under your boots. For an outside observer, your signals slow, their color sliding to red, heartbeat to bass note, frame to frame, until you seem to stall on the very brink, and then fade to black. For you, falling freely, nothing sticks. Your heartbeat stays your heartbeat, your thoughts tick normally. Gravity doesn't feel like a force when you ride its curves. It feels like the absence of one. Then the horizon itself, not a surface, not a wall, just a boundary set by geometry. Cross it, and every possible future points inward. Even light, which has spent 13.8 billion years outrunning nearly everything, discovers a place it cannot leave. There's no drum roll, no splash, just a quiet subtraction of options. Outside, the universe continues. Inside, the map folds until every arrow points the same way. Your body would not thank you for visiting. Tidal forces are the true bouncers at this door. For a small stellar mass black hole, the kind that can drift rogue through the galaxy, those tidal forces become brutal well before you reach the horizon. The difference in gravity between your head and your feet grows so steep that you'd be stretched thin, spaghettified, long before any philosophical reflections could occur. For a supermassive black hole, the horizon can be crossed gently. For a city-sized one, the warning comes early and loudly in the language of pain. We are, mercifully, imagining from a safe distance. There's a ring a bit farther out where stable circular orbits vanish, the innermost stable orbit. For a non-spinning black hole, it sits at 3 times the horizon radius. Nothing can maintain a tidy loop inside that line. Orbits decay. The path inward becomes a slide. If matter were present, it would blaze there, heating into an accretion disk, X-rays shouting across the dark. Our visitor is lean and quiet. It travels light, and so there's no rim of fire, only starfields twisted into luminous wreaths. All of this, photon spheres, horizons, tidal knives, was once pencil math on paper. In 1974, a young theorist added heat to the picture. Stephen Hawking's calculation that black holes are not perfectly black, that quantum fields near the horizon allow a faint, cold radiation to leak away. It was a historical swerve, the day thermodynamics and gravity shook hands over the edge of the abyss and agreed that even darkness has a temperature. No telescope in your backyard will ever spot that glow from a stellar remnant. It is unimaginably faint, but the idea matters. It says horizons have secrets they don't keep forever. You step into a planetarium one rainy afternoon, not for answers, just for comfort. The dome dims and a presenter guides a slow drift toward a simulated horizon. Stars bend and redden. A laser pointer traces the photon sphere. A soft voice mentions Hawking's insight, how the slowest fires in the universe whisper from an edge that isn't truly an edge. Mid-sentence, the projector freezes, a glitch, and the whole dome hangs in a perfect, silent tableau. Red arcs, a dark circle, time suspended. A child somewhere in the dark whispers, "Wow," so softly you feel it in your ribs. The technician taps a key, the cosmos resumes. It is an unusual moment, but it feels exactly right. The universe caught for a breath between frames. Later, you make tea and catch yourself smiling at a small domestic myth, the missing sock black hole inside every dryer. You know better, of course. Socks crawl under beds, not through horizons. But it's a useful joke for something so grave. A black hole is the absence of return wrapped in geometry, the cleanest line nature draws between outside and gone. If humor makes the line easier to look at, so be it. In this unified world where straight lines are merely local agreements and clocks depend on where they sit, the event horizon is the most honest boundary you can name. It doesn't bargain, it doesn't rage, it simply states the rule that mass and curvature have written together. Past this, all futures converge. That rule has sculpted galaxies, fed quasars, rung the universe like a bell when two horizons collided and LIGO felt the shiver. It is present here too, quiet and austere, moving through our neighborhood with the courtesy of something that doesn't need to hurry. You step back from the brink, out of your thought experiment into the tangible world. Rain thrums on the gutters. The air in your room smells like wet pavement and old books. Somewhere, a refrigerator clicks. A bus sighs at a stoplight. The floor holds steady under your feet. The horizon remains a rumor out there, a mathematical address, an approaching possibility that for the moment changes only the smallest things. Yet even knowing that, you can't help but glance up at the ceiling, as if the dome were still above you, as if the stars were still taking on their soft, impossible shapes. The secret of the horizon, then, is not menace. It is certainty. It is the place where the universe stops offering detours and simply points. You pull a blanket close, breathe in, breathe out, and feel grateful for the distances that still lie between you and that sharpest of edges. Outside, the rogue traveler keeps to its path. Inside, the kettle sings, and the night, despite everything you've learned, remains tender and slow. Long before you ever looked up at a night sky and imagined a black hole as a mysterious monster, the universe had already hosted close encounters with these dark wanderers. You're not the first system they've brushed past, and you won't be the last. Out there, in the quiet gulfs between stars, black holes have been passing near suns for as long as there have been suns to pass. The evidence is scattered, written in the shapes of galaxies and the chemistry of stars. Astronomers studying stellar motion sometimes find anomalies, stars that move too fast, as if they were kicked by an unseen hand. Others orbit something invisible, their paths as regular as clockwork around a point where no light shines. In certain regions, whole clusters of stars seem stretched, distorted, as though they once felt the pull of something that swept through and moved on. One historical clue comes from the way galaxies grow. Our own Milky Way has absorbed smaller galaxies over time, and the trails of their stars still weave through the sky. Some of these mergers may have been shaped by passing black holes, either rogue ones between galaxies or the central giants in the galaxies themselves. A massive visitor could disturb orbits, triggering waves of star formation or scattering stars like leaves in wind. And then there are the runaway stars. Some streak across the galaxy at hundreds of kilometers per second, too fast to be bound to the Milky Way. Many are thought to have been flung outward by encounters with black holes. In some cases, binary star systems torn apart when one partner fell in and the other was launched into the dark. You think about this and realize a black hole doesn't need to consume to change things. Just its presence, just its gravity, can sculpt an entire region of space. Our current visitor is not unique in its journey. It is part of a long, silent tradition of close calls. One random, almost whimsical example comes from the fossil record of Earth. About 2 million years ago, a nearby supernova blasted our planet with a rain of cosmic rays, leaving traces of rare isotopes in ocean sediments. While that event wasn't caused by a black hole passing close, the dying star might have collapsed into one. Somewhere out there, its remnant could still be wandering, a ghost of the explosion that once dusted Earth's surface with iron from another sun's core. In more recent history, astronomers have identified at least a dozen rogue black holes in our galaxy using gravitational microlensing, watching for the brief brightening of a background star as the dark mass passes in front. One was estimated to be just over 5 solar masses, about the same size our visitor might be. It passed quietly, not disturbing anything in our neighborhood, but it proved that these wanderers exist, and that they can drift near without notice until the evidence is undeniable. In this unified world, past and present are stitched together by the same rules. The same kind of visitor that now bends our starlight and nudges our planets once brushed other systems, twisted other skies, altered other destinies. We are part of a much older pattern, one that cares nothing for whether we call it history or danger. You lie back, imagining those long-ago encounters. Alien skies seeing their constellations stretched, their planets shifted, their comets awakened. Somewhere, perhaps life, on another world, looked up with the same mixture of awe and unease you feel now. And when the black hole moved on, they were left with a sky forever changed. It's a quiet kind of kinship across time and space. The universe has always been this way, full of travelers, full of encounters, full of stories no one ever told until the science caught up to see them. The black hole has no intention, no malice, but on Earth, its slow, relentless approach is enough to stir both wonder and fear. Humanity is not built to ignore something like this. The headlines begin mild, tucked between political news and sports scores. Astronomers detect rogue black hole near solar system. Then the tone sharpens. Gravity from interstellar visitor may alter planetary orbits. By the time the first comet flares spectacularly in the night sky, the story is everywhere. You watch the reactions unfold in waves. Scientists speak carefully, measuring each word. Engineers talk about mitigation, about tracking debris, about building new early warning systems. Politicians use the event to call for unity. Some sincerely, some with the kind of opportunism you've seen before. And the public? The public does what the public always does. They make art, memes, hashtags, songs, and conspiracy theories, all mixed together into a global conversation that is equal parts serious and absurd. One lighthearted moment becomes a viral comfort, a late-night comedian pretending to negotiate with the black hole, offering it the moon in exchange for sparing Earth. It's silly, but in the laughter there's a small release of tension, a reminder that humor can still live under the shadow of cosmic forces. Meanwhile, serious plans take shape. Space agencies draft joint mission concepts, massive solar sails to deflect dangerous asteroids disturbed by the black hole's gravity, high-energy lasers to vaporize smaller incoming debris, even wild proposals for planetary tugs, coordinated gravitational assists using large asteroids to subtly adjust Earth's orbit if needed. Some ideas are feasible, some are pure fantasy, but none are ignored. Private space companies join in, sensing both responsibility and opportunity. A billionaire announces funding for an Arkship initiative, long-duration spacecraft meant to carry human life beyond the solar system should things turn catastrophic. The idea splits opinion. Some see it as visionary, others as escapist, a luxury for the few. The debate rages, but the design work begins anyway. And then there's the quieter, more human response. Families book trips to remote places with dark skies, wanting to see the strange bending of starlight for themselves. Schools host gravity nights where children gather to watch simulations of space-time warping on big screens. In small towns, amateur astronomers set up telescopes in parking lots, inviting strangers to step up and look at the stars through a lens, to see the universe not as abstract numbers, but as something you can feel in your bones. The randomness of everyday life weaves through it all. In one city, a power outage during a black hole update broadcast leaves a neighborhood chatting by candlelight, debating whether they'd rather live on Mars or Europa if they had to leave Earth. In another, a couple gets engaged during a meteor shower sparked by Oort cloud debris, deciding that if the universe can fling ice across light years, they can at least promise to be there for each other. You realize that, while the black hole may be silent, its presence amplifies humanity's voice. Every fear, every hope, every dream pulled into sharper relief. We are small, yes, but we are not passive. Even knowing the limits of what can be done, people still reach for tools, plans, and each other. In this unified world, where cosmic events ripple into human hearts, the approach of the black hole becomes more than a scientific challenge. It's a mirror. It shows us how we react when something vast and indifferent moves through our sky. Some build, some laugh, some cling to the familiar, and some look up in awe. And somewhere, beyond all the speeches and sketches and prototypes, the black hole continues on, unaffected by any of it, a silent traveler that will not stop for our worries or our wonders. The changes in the inner solar system arrive so slowly at first that they feel like background noise, the kind of variation you might chalk up to an unusually hot summer or an early frost. But the data shows otherwise. The orbits of the inner planets are no longer the same clockwork ellipses we've known since Kepler's time. The shift begins with the moon. Laser reflectors left by Apollo astronauts allow scientists to measure its distance to within a few centimeters, and the numbers start whispering a new story. The moon is drifting slightly faster than before, tugged in ways Earth alone can't explain. The tides, already touched by the black hole's far-off gravity, now carry a different rhythm. Coastal communities notice tiny changes in high tide marks. It's not dramatic, not yet, but it's there. Then, over months and years, the length of Earth's year alters by fractions of a second. Astronomers and navigators adjust their charts, adding micro-leap seconds and quietly recalibrating their instruments. To you, the seasons still arrive in order. Spring blooms, summer heat, autumn leaves, but their timing begins to slide ever so slightly. Winters grow a touch longer, summers a touch shorter, as the planet's path around the sun shifts in response to the black hole's pull. Mars feels it too. The rovers trundling across its rusty plains don't notice, but the orbital mechanics do. Transit windows between Earth and Mars shift by days, then by weeks, forcing space agencies to rewrite their mission plans. Venus, wrapped in its thick cloud blanket, drifts just enough that radar mapping needs correction. Mercury's already eccentric orbit becomes even more unpredictable, its dance around the sun bending to the new gravitational choreography. One random, almost comic moment captures the public's attention. During a televised spacewalk from the ISS, an astronaut jokes about having to recenter the Earth in their viewfinder because the whole solar system's getting a little tipsy. It's not technically accurate, but the clip makes the rounds anyway, becoming a meme under the caption, "Steady there, planet." For scientists, there's no humor in the long-term models. If the black hole came much closer, its pull could destabilize the inner planets entirely, possibly ejecting some from the solar system or sending them into the sun. But in the current projections, the changes remain subtle. Disruptive, yes, but not catastrophic. The solar system is a patient machine, and even under the black hole's influence, its gears turn slowly. Still, the interconnectedness is impossible to ignore. A tiny change in Earth's orbit affects climate patterns. Altered tides reshape coastlines. Shifting lunar distance changes the length of days. In this unified world, every alteration ripples outward. From the paths of planets to the migrations of birds to the timing of harvests. You sit in your backyard one evening, watching the moon rise a little farther north than you remember from childhood. The air smells of damp soil and cut grass. Somewhere a train passes, its horn low and distant, the sound stretching over the fields. You think about how fragile this balance has always been, how even a quiet guest on the edge of the system can reach across billions of kilometers and touch the shape of your days. And above it all, invisible to the eye, but heavy in the mind, the black hole drifts onward, its path cutting a slow arc toward whatever lies next. For years, the black hole has been a shadow in the background, tugging, bending, stirring, but never quite making its move. Now, its path reaches a turning point. The models shift from approaching to passing, and a cautious optimism spreads through the observatories and mission control rooms. It won't hit the sun. It won't swing through the planets like a cue ball scattering marbles. Instead, in a cosmic stroke of luck, its trajectory will take it on a near miss past the solar system's heart. Close enough to leave fingerprints, far enough to let us keep what we have. But far enough is a relative term. As it arcs past, the black hole's gravity brushes against the sun's domain with a last, lingering caress. Planetary orbits twist slightly in its wake, settling into new shapes they will keep for millions of years. Mercury and Venus shift most subtly, tiny changes in their perihelion, the closest point in their orbit to the sun that only precise instruments will notice. Mars gains a fraction of speed, Jupiter a fraction of distance. The sun itself feels the pull. Its outer layers ripple in ways normally caused by magnetic storms, producing odd, shifting patterns in the corona. Solar physicists watch in fascination, gathering data they could never replicate in a lab. For a few days, the gravitational ballet between star and visitor is at its peak. A slow-motion exchange between two titans, one blazing with nuclear fire, the other cloaked in perfect darkness. Comets still fall inward from the disturbed Oort cloud, their long tails catching sunlight in delicate arcs. Meteor showers continue to grace the skies, each one a reminder of the wave of debris set in motion years earlier. Some of that debris will circle the sun for centuries, long after the black hole has moved on. There's an unusual, almost poetic side effect. As the black hole passes beyond the sun's far side, the gravitational lensing reaches its most dramatic moment. For a brief window, the sun's light, normally too bright to see the stars around it, is bent into a ring that frames the black hole's silhouette. Observatories around the world capture the image, an impossible halo of daylight stars wrapped around a void. The photo becomes an instant icon, printed on magazine covers, murals, and classroom posters. On Earth, life continues. Tides settle into their new patterns. Satellites adjust their courses for the final time, and the subtle drift of the moon finds a new steady pace. The seasons keep their altered rhythm, longer winters, shorter summers, but they stabilize. The worst-case scenarios fade from the headlines, replaced by stories of what was learned, and how close we came to something much worse. A random lighthearted news piece reports that a group of hobbyist astronomers in New Zealand held a goodbye black hole barbecue, timing it to the exact hour the object reached its closest point. They grilled in the cold night air, raised glasses to the darkness, and played recordings of the Event Horizon Telescope's data sonifications as background music. It's silly, but it feels fitting. A human note in the middle of a cosmic event. In this unified world, you realize escape doesn't mean the past disappears. The solar system is not what it was before the black hole arrived. It has been resculpted quietly but permanently, The paths of worlds shifted, the shape of the sky rewritten, and somewhere, already dimming into the backdrop of the Milky Way, the black hole drifts onward, silent, patient, carrying no memory of the place it just changed forever. The black hole is leaving. Not quickly, nothing of such mass moves quickly by human standards, but with the same steady inevitability it had when it arrived. Its gravitational hold on our system loosens, and the disturbances that once grew with each year now begin to fade. The comet influx slows, the bending of starlight softens. The tide of change turns outward. It doesn't vanish from our instruments all at once. Astronomers track it for years as it drifts deeper into the galactic night, its path marked only by the slow return of the stars behind it to their normal shapes. The distorted arcs shrink. The faint halo of bent light thins. Space, like a sheet settling after something heavy has passed over it, relaxes back toward its old form. The solar system, though, is not the same as it was before. The moon's new orbit will outlast continents. Earth's slightly altered year will be the quiet signature of the visitor for as long as calendars are kept. Out beyond Neptune, a handful of icy bodies now move on paths that will never bring them back. Others will, centuries from now, return in long, glowing arcs, their origins traced to this time. Jupiter and Saturn carry subtle wobbles in their orbits, like echoes of a deep bass note that has already faded from hearing. In this unified world, permanence is a word without teeth. Even something as ancient as the solar system can be remade in the span of a single cosmic encounter. The changes don't feel catastrophic, more like the rearrangement of furniture in a familiar room. You can still walk through it, but you notice the shift every time you reach for something that isn't where it used to be. The human chapter of the story becomes one of memory and record. Observatories archive every image, every spectrum, every model. Museums mount exhibits on the passing black hole, filled with telescopes, simulations, and the now famous photograph of the sun's haloed silhouette. Students who were children when it arrived grow into scientists, artists, and storytellers, their imaginations shaped by the knowledge that something from the deep past brushed our doorstep and moved on. Life goes on. Crops are planted to the rhythm of the new seasons. Migratory animals follow their recalibrated routes. Satellites orbit in their adjusted paths. The black hole becomes less a daily concern and more a historical fact, the kind of thing people say they remember, even if they mostly remember the photographs and documentaries. One last time, you step outside on a clear night. The air is cool and the grass is damp beneath your feet. Overhead, the stars shine without distortion. They look the way they did before. Or maybe your mind has already accepted this new before as normal. Somewhere out there, farther than your eyes could ever see, the black hole is still moving, headed for a new patch of darkness, where other worlds may one day feel its touch. You think of it not as an invader now, but as a traveler, one of countless in the galaxy, bound to nothing but the rules of gravity and time. And you wonder how many more such travelers have passed this way before, unnoticed, and how many will pass again after you're gone. The night is still. The stars are sharp. The universe, vast and indifferent, has kept its pace. You pull your jacket tighter against the breeze, take a last long look, and turn toward home. The story is ending now, the way a tide slips back into the sea. The visitor is gone, but the space it moved through still feels touched, as if some deep current has passed through the bones of the solar system and left a faint, persistent hum. You breathe in slowly, letting the air settle in your chest, and you can almost believe you hear it. Not a sound, exactly, but the quiet shape of something vast that has moved on. Above you, the constellations rest in their altered forms, as steady now as they will be for centuries. They are a reminder that change, even when slow and silent, is still change. Somewhere, far beyond even their light, the black hole keeps drifting. Perhaps toward a future encounter with another star, another set of worlds, another set of beings who will look up and feel that mix of awe and unease you once felt. Your steps are slower now. The night feels longer, as if time itself has relaxed. You think about how fragile our arrangement of planets and seasons really is, and how even an invisible traveler can reshape them without so much as a whisper. And yet, here you are, the ground steady under your feet, the stars still burning, the air still sweet and cool in your lungs. In the end, it's not destruction you remember, but perspective. The awareness that in the grand weaving of space and time, your thread is both impossibly small and completely part of the pattern. That in this unified world, everything, from the bending of starlight to the turning of tides, is connected. The hum fades, the stars hold, and the night, once more, belongs entirely to you.